So welcome to Cordless IP version 2. In this market introduction, we will deal with the new DECT over IP product of Unify. The corresponding section is the training for OpenScape Cordless IP version 2, which is the DECT over IP multi-cell solution of Unify. The training will consist of the following sections. I give an introduction into the entire product. What is that about? What are the components? We discuss the first steps of setting up and deploying OpenScape Cordless IP version 1. That's some operation hint regarding base stations, regarding handset, regarding environment and so on, configuring the system. Then what is the configuration? It's again web-based, but the web configurator looks rather different than the web-based management from the iPass Cordless IP version 1. Then we go step by step through the several configuration items, which start with the network administration, continue with the base stations, PBX profiles, mobile devices. So going step by step through the entire system. Then finally some settings in the end, telephony settings, online directory, system settings, and we end with a section on diagnostic and troubleshooting a bit. Section 1 is the introduction. The introduction covers first the entire system. You see here a picture of the entire OpenScape Cordless IP system, which consists of base stations BSIP2 and the base station BSIP2. We can have the ones which where the antennas are distributing the radiation, like the three ones in the second line, and the ones which doesn't emit electromagnetic waves through the antennas. That's the first one. The first one is the manager or DECT integrator, and the other ones are the ones to which we connect the mobile phones later on. Then we have an administration PC. That's the one left to the DECT manager, and 3 phones and the Unify communication platform. In that example, an OpenScape Business, but we can use here an OpenScape 4000 or an OpenScape Voice as well. We have several systems or components in the system. I already mentioned the DECT manager and DECT integrator, and we now come to those. First of all, the DECT integrator is the central management and configuration unit of the DECT multi-system. It integrates the handover domain, which in this context we will name clusters, managed by multiple DECT managers to one roaming domain. It contains the central DECT subscriber database, provides a web user interface for subscriber information, which we will go through in this training, provides access to the configuration for all DECT managers and base station in the synchronization hierarchy, and acts as provisioning server for the DECT registration and for the IP SIP registration. It's the interface to the communication platform, and in small and medium installations, the integrator and the DECT manager are located on the same device. In large installations, the DECT integrator will be provided a separate virtual machine that can be installed on the computer, while the DECT managers are always located on BSIP base stations. Then we start with the next component, which is the manager. The manager is the management unit for a group of base stations, which we call the roaming domain or the cluster, and at least one DECT manager must be used for each installation. The DECT manager enables the division into subnets, which we call the cluster formation, and manages base station synchronization within the cluster. The current release of OpenScape Cordless IP version 1 supports only one DECT manager. As we go through the components, the first most important component is the BSIP2 base station. The BSIP2 DECT base stations are completely new design. There's nothing in common with the previous ones. And these base stations form the cells of the DECT telephone network. They can provide up to 12 DECT full slot pairs with 1 zero blind slot, 1 we need for synchronization, so that in total 10 are left, or finally 10 are left for the telephone calls. And they can provide up to 6 DECT long slot pairs in wideband mode if we have a high definition voice transported over the DECT network, so that we can have 5 calls plus synchronization plus the corresponding administration in one of these boxes. Then the handsets, up to 250 handsets can be connected and 60 calls can be made simultaneously in the system, and that simultaneously means calls, email checks, connections to online directories and the info center. That can be done in small and medium deployments. In large deployments, which will be, however, subject of a subsequent release, this will be extended, like in Unify Cordless IP version 1 of the large solution, to 20,000 handsets and 3,000 parallel calls. Subscribers can accept or initiate calls in all DECT cells with the handset by roaming, and can also switch between the DECT cells during the call in the handover domain. The handover is only possible within the same cluster. That's a restriction when compared to OpenScape or to Unify Cordless IP version 1, where we have the sync and handover also between several media gateways. So the entire architecture is depicted here. We have several handover domains which we call cluster, for example here and here. Here and here and here. Each of these domains has one DECT manager. That's the one which has no radiation here. The radiation is missing, like here and here as well. And we have base stations. They form an handover domain, and there is a handover possible within these domains, within the yellow one, within the purple one, and within the turquoise one. However, there's no handover. Only roaming is possible between these clusters. In small deployments, up to 10 base stations, you can also have the situation, and it guarantees the access to the centrally configured IP configuration and the directories, for example, which are in here, and handover between clusters is not possible. Roaming is possible everywhere. But only for the handover we are restricted. We are restricted to the domains. In deployments, there are 3 deployments, of which we have the first 2 deployments already in this first release. This is the single cell deployment or 2 single cell deployment. In a small deployment, we have 10 base stations and up to 50 handsets. Then, in this case, the DECT integrator can also be an antenna, and is included in these 10. Can be included in these 10 base stations. In the medium deployment, up to 60 base stations and up to 250 handsets. In that case, the corresponding DECT manager, DECT integrator is not allowed to work as base stations. It's then a dedicated base station, which is not used for handsets to log on. That can also be placed somewhere else in the corresponding environment, because it doesn't need to have any DECT overlap with the other ones, because it's just the managing unit. And in that case, we can have 60 base stations plus manager, meaning 61 base stations with antennas, the 6 without antenna, and up to 250 handsets. Then we are going to have a multi-cell large deployment with the same expansion as we used to have in Unify Cordless IP version 1, but that will be subject of a subsequent release. Then having a closer look at the hardware, the BSIP2 workstations have the LAN slot. They have their antennas, which are now mounted at each side of it. We have the device button. We have the LEDs, and we have the wall mounting slots. Please note that the size and the wall mounting slot is made in a way that you can just replace the BSIP1 by the BSIP2 base stations. They have the same wall mounting slot, so you don't need to redo the screws. You can use the same screws, just take out the old one, put in the new one. Also, the shape of the base station is so that it fits in all places where the old one was. This includes the outcase box, which you used to deploy the corresponding station outside. Then we have even more details of the hardware. The LAN slot shown from the top view or bottom view, and the package contact. There's always one BSIP2, 2 antennas, and the security leaflet shipped within one box. The next chapter, per steps, discusses the basic steps you need to deploy such a system. And the steps are shown on this transparency. First step, you need to perform a DECT measurement and site planning. And during this planning phase of your DECT network, you should have created an installation plan for the DECT managers and base stations where to place them. And we refer to the OpenScape Cordless IP site planning and measurement guide, which is actually contained in the service guide of OpenScape Cordless IP version 2. Then you connect devices to a local network. We have power over Ethernet class 3. If you don't have that available, it's also possible that you use a power injector like before. Then you need to register at least one device as DECT integrator or manager. So if you have one cluster, it's sufficient to have one manager. If you have 2 clusters, you need 2 DECT managers. Then you mount physically the devices at the plant location. Configure your local network settings via the web configurator. In that case, you need a PC to connect to the local network so that you can configure your telephone system via the web configurator. Then perform a firmware update, because normally the base stations shipped will not have the most recent firmware on it. So the first thing you will have to do normally is that you update the firmware. However, we will see later that's rather simple. Then register the base stations to the telephone system, configure base station synchronization, or do this vice versa. This doesn't matter. Configure the communication platform or provider and register all handsets and perform the handset configuration. All the handsets that are used to make calls in this OpenScape Cordless IP version 2 must be registered. When registering, the handset permanently gets a voice over IP connection with the corresponding communication platform. Then finally, we create a backup and save the configuration. So when installing the base stations, take into account that the technical conditions for positioning and the installation guidelines, which are described in the OpenScape Cordless IP version 2 service guide. This includes the site planning mentioned earlier. Then install the DECT base stations on positions you've determined when planning or measuring your DECT wireless network. And mentioned that before. The OpenScape Cordless IP version 2 device acting as integrator or DECT manager can be installed anywhere within the range of the local network. It does not need to be installed in the coverage area of the DECT wireless network. As soon as you don't use the antennas. Of course, if you want to use the antennas of the DECT integrator, DECT manager in the small solution, then you need to be in the coverage area. And finally, the devices are intended for wall mounting. So installing the device in detail. First you need to pull the upper part up, so like this, first up, and in the second step, open it. Then the flap opens like shown here, and you can plug in the LAN cable here and on the router with the other end. Please note, I mentioned it earlier, that we use the power over Ethernet class 3 here. Then finally close the flap again. Mounting the antennas, you can mount the inbuilt antennas. So devices that intended to be used as base stations should be equipped with external antennas supplied. You can also use third-party antennas. For devices which are used as DECT manager, DECT integrator only, you can omit the antennas. Wall mounting. BSIP2 is intended for wall mounting. The picture and the instructions how to wall mount the device are shown here. Please note that this is the same procedure than for the older BSIP1 base stations of high-pass cordless IP version 1, so you can reuse all the mounting material you have used there. And if you want to replace high-pass cordless IP version 1 with OpenScape cordless IP version 2, you just have to replace base stations one by the other. No screws need to be redone. And it also fits in the same output case as before. Same as before. Then defining the device role. So the base station can be simply a base, or BSIP2 can be simply a base station. BSIP2 can also be DECT manager or DECT manager and integrator. And as DECT manager or DECT integrator, the BSIP2 can have a static or dynamic IP address. So these are the several roles for the device. And on delivery, all OpenScape cordless IP version 2 devices are configured as base stations. And in your deployment, you need to set up at least one device as integrator or DECT manager. To do that, you use the device button on front of the box to assign the corresponding role to the device. The following settings for the device role are possible. First of all, it can simply be a base station, like on delivery. Secondly, it can be a DECT integrator or DECT manager with dynamic IP address. And thirdly, it can be a DECT integrated DECT manager with fixed IP settings. The device role is set in the following way. First of all, you press the device button for at least 10 seconds. That's shown in the picture here, until all LEDs are off. As soon as all LEDs are off, the device is in programming mode. Then you have three possibilities. You can press once. This puts the device in the role of DECT integrated DECT manager with dynamic IP settings. Or you can press the device button twice. This brings the device in the DECT integrator manager row with fixed IP settings, or you can press the button 3 times. That then puts the device in base station mode, and the mode is then shown also by the LEDs. As DECT integrator with dynamic IP addresses, you see 2 blue LEDs. As DECT integrated DECT manager with fixed IP settings, you see only the right ID blue. And in the base station mode, you see the right LED in green. Finally, I want to mention that with fixed IP settings, the IP address which is assigned to the device is 192.168.100.43.1, and it's a class C network. So then after setting the role of the device, you need to save that. And to do so, we go to the next page. That means we activated the role. And now, regardless what role you have set, so regardless which LEDs you see here, you press the button longer than 3 but shorter than 9 seconds. Yeah, at least 3 but shorter than 10 seconds, so 3 to 9 seconds. This assigns the selected role to the device and then afterwards reboots the device. You can see that the device is rebooting on the fact that those LEDs are red, and afterwards, after rebooting, the device comes up again in factory default, and depending on the role you have assigned, you see one of the following LED patterns, either for the manager solid blue and solid green from the left to the right, or on the base station you only see the left LED and it's blinking green. When changing the device role, this always means that you reset the device and the device after that comes up in factory default settings. The next paragraph deals with the operation hints, which should make your life easier. So we give you some particular and also some general hints about DECT, which can be useful when working with OpenScape Cordless IP version 2. First of all, the patterns of the light emitting diodes of the LEDs. They can show different operational states. First of all, in general. Secondly, for base stations. Thirdly, for DECT Manager in the standalone mode, where the DECT Manager is not used as base station in parallel. And finally, for the DECT Manager with base station in parallel on one box. Well, first of all, in general, we had that already. 2 red LEDs means the device is booting. 2 alternate blinking blue LEDs means the firmware update is in progress. If we have alternating blinking of red lines, that means there's no line connection or no IP address is configured for the box, and connecting to the DECT Manager with not yet having a DECT Manager connection established means that the left LED is blinking in green. And for the base stations, once the base station has connected to the DECT system, that just continues here from the last view, then the right LED becomes solid green. Synchronized and DECT ready means that 2 LEDs are green on the base station. And with DECT traffic, first of all, the right LED starts blinking quickly. And if that slows down in the end, then we have DECT overload. The manager means that we have no DECT base station inside and the corresponding DECT manager is active. Then we have a solid blue LED on the left-hand side. Finally, with system traffic or ongoing calls, we have a quickly blinking blue LED on the left and a solid blue LED on the right. Then the DECT manager with base stations, again with the same meaning, not synchronized but DECT ready. We have the solid blue LED on the left-hand side. That goes together with synchronized base stations. The synchronized base station, then we have solid blue on the left and solid green on the right. Synchronized system traffic but no DECT traffic means that we still have a solid green LED on the right-hand side, but with quickly flashing blue LED on the left side. Then, if both LEDs are flashing quickly or blinking quickly, and then we have a synchronized base station with ongoing DECT traffic, and finally, if the right LED slows down, this again means that we have DECT overload in the last case. These are the LED patterns of the BSIP2 base stations, which show you the different operational state of which the device currently is in. So then you can also change the mode or reset to factory defaults via power procedure. is especially useful for devices which are mounted in a region where it is not easy to go to the device itself. For example, it can be mounted in an outdoor case, they can be mounted on top of a pole or somewhere else. So it's also possible to do the factory reset or the reset of a device just by a power procedure. First, you remove the power supply from the device. You mean you unplug the LAN cable. With that also the power is gone. Then you replug the cable and the power is back, and the reboot starts. If the boot process is not interrupted, then a standard reboot is performed, and the device comes up in the previous mode and with the previous data. However, you have the possibility to interrupt the boot procedure after 30 seconds, the earliest, and 40 seconds the latest, so between 30 and 40 seconds. You do this once, 3 times, or 5 times, and this is different meaning. If you interrupt the reboot process once, then the device is reset as integrator or DECT manager with dynamic IP settings. And if that's a new role, then a factory reset is made and all configuration is lost. 3 times means the device is reset as base station, and 5 times means the device is reset as DECT integrator or DECT manager with fixed IP settings. Then using a handset control key functions, you have several control key functions which you see here. The up, down equals telephone book, left meaning internal, right meaning mute. These keys also allow you to navigate through functionalities provided by OpenScape Cordless IP, and we discussed that here. And in that description we are going to use symbols like that for the corresponding arrows. So that is the right arrow, and that is the central or control key. Then open the local directory of the handset, press the down key briefly. Open a list of available online directories, press again the down key, but you should hold that. Open the main menu, press the center or the right key, center or right. Open the company directory that was the internal before, press the left key, and in sub-menu selections and entry fields to confirm a function you can press the control key. And then control key functions during a conversation. To open the directory you can press the down key. To mute the microphone, press the right key. We don't have that on this drawing here. To open the company directory if available and configured, for example to initiate external or consultation calls, and then you just press the left key, or the sometimes also labeled as int key for this purpose. And to adjust the loudspeaker volume for the receiver and the hands-free mode, you can press the up key. The functions of your telephones are displayed in a menu that consists of several levels. That's the usual function of these keys, selecting and confirming functions. You simply press the OK button in the middle of the control key. Also select OK or press the middle of the control key. One menu level back using the back key. For example, to change to the idle display, press and hold the dial key. Switch functions on off, then you use the functionality change on off and activate deactivate options by selecting the activated or not activated option in the menu of the phone. In this section we deal with the configuration, configuring the system, and we have a look at the new web configurator of OpenScape Cordless IP version 2. To configure the system, we use the web configurator, and that's the tool which we use for system settings. In addition to that, handset specific settings are preset on your handset. The web configurator we use to set up the OpenScape Cordless IP version 2 system and to configure the DECT network. Prerequisites for using the web configurator is that we have at least one DECT integrated DECT manager. We are using a standard web browser. We have a connection over LAN, and finally the web configurator provides single user access. That means only one user can log on to it. If I'm logged on a PC here and my colleague wants to log on to the same system from a PC somewhere else, then the second person can log on, but then the connection for the first originally connected administrator is terminated, so then the newly logged on user has again single user access. And in order to connect, I need the IP address of the device. When configuring the system, we have to set the IP address first. And in order to have access to the IP address, we need to know what the IP address of the device is. So for example, if you use DHCP, you know that your system has an IP address, but you don't know which one, and you have to find that out. First of all, in that case, you have to look up the DHCP server, and in the list of the current IP addresses on your DHCP server, you find also your DECT manager. You find your DECT manager normally by the MAC address, and the MAC address can be found on the rear of the device. And if necessary, contact the network administrator of your local network to obtain the IP address of this device. Your DECT manager's IP address may be changed occasionally depending on the DHCP settings. That means if you have a dynamic IP address and the lease of that IP address expires, then the DHCP server can assign a new IP address to your device. If the IP address is assigned statically, then the default value for the IP address is 192.168.143.1. The web configurator default login. The default login to the web configurator is simply the user admin and the password admin. The web configurator features help list and appearance. In the DECT configurator, you can click on the question mark parameter to obtain the parameter description. You also have a full online help available that gives you the function descriptions for the entire web configuration page. In this case, you have to click on the question mark in the upper right corner of the page, and then in the online help you can browse through the online help, open tables of contents and search. Finally, you can change the appearance of a list in the web configurator by filtering, sorting, displaying, or hiding columns on browsing through entire lists and stuff like that. The web configurator administration tree is shown here. On the top level you have two sections, one of which is settings, the other one being status. Then for settings we can do the network settings, the base station settings, providers or PBX profile, the mobile device settings, some configurations for telephony, for online directories, and the general system configuration. Then in status we have an overview, statistics on base stations and on incidents. OpenScape Cordless IP version 2 network administration. In the network administration we first have to set up the interface. In many cases that will nowadays be done dynamic, so that the parameters we see here below, they will be set automatically anyway. You can select here the network type IPv6, IPv4, dynamic or manual, and depending on what you've selected here, manual or dynamic, you have to specify IP address, subnet, mask or prefix, standard gateway, preferred DNS and alternate DNS. Then on network LAN, next section here in the tree, network LAN, we can configure the VLAN tagging, the VLAN identifier, and the VLAN priority, which gives us the possibility for VLAN separation of the device to enhance the quality of network quality of service. OpenScape cordless IP base stations. As next section, we now deal with the base stations within the network, which form the DECT cells. The base stations need to be confirmed, activated, and synchronized. And the base station administration is done in two tables. First of all, a list of the connected base station list is shown in the configuration, and secondly, a list of pending base stations is displayed. The pending base stations are those base stations that are recognized over network, so they are located in the layer 2 networks of one of the DECT managers, so they can be found, but they are not yet connected to a particular DECT manager. Base stations and the pending base stations. This transparency shows the aforementioned configuration with the connected base stations on top and a list of pending base stations on bottom. And we now have to select one of the pending base stations, click on the pen besides them in order to configure them and add them to the connected base stations. Initially, like you see it here, only the base station local, that is the local base station on which the DECT integrated DECT manager runs, and that's also shown here, is a part of the synchronized base stations. And the two newly added to the system, like this one and the last one here on this page, they are not yet integrated and synchronized with the DECT network we see on top of this page. So we start the configuration by clicking the Edit button of one of these pending base stations and add them to the corresponding cluster. The pending base stations list shows the automatically recognized DECT base stations in the network that have not yet been registered. To integrate them, they need to be confirmed and activated. That's what we are going to do now. And OpenScape Cordless IP detects the base stations by their MAC addresses. So we click on the base station that we want to add to our system, and the data page for the base stations is open, and we can start configuring it. Now, base stations confirm base stations. On this transparency, we see the configuration of a particular base station. We see the MAC address. On top, then we can assign a name, DECT manager, status for synchronization, the IP address type, in this case dynamic, the IP address, several identifiers, the so-called RFPI. Come back to that in detail in one of the next transparencies. Firmware version of that base station, reduce transmission power for external antenna operation, and activate base station. Once I've selected all the configuration, I click Set, and then the base station will be integrated and rebooted. I can also reboot the base station here or delete the base station. So then we discuss the general information which is contained on the last form. So first of all, the connections for the connected base station has the following information. First of all, the MAC address, which is just the hardware address of the base station. The base station name I can assign to it. Then we have the RFPI, which consists of the radio, or which is the radio fixed part identity. That is a unique name of the base station in the multi-cell DECT network, which consists of the primary access rights identity, which is the PARI, plus the RPN. The RPN is the radio fixed part number. and this is an hexadecimal number. And by that number, each base station is identified uniquely. The name of the deck manager the base station belongs to, that's currently always local. Then the firmware version that's currently installed on the base station, and the synchronization status of the base station, which can be one of the following. It can be offline, then synchronization status is not available. It can be deactivated and it's available but not activated. It can be no sync, that means the station is activated but not synchronized. And then sync means activated and synchronized. Sync overload again means synchronized but we detect traffic overload. The IP address type is copied from the settings of the DECT manager on the IP network. We can change that address type, and the settings for the DECT manager and the base stations do not have to match. So for the base stations, for example, I can use IPv6 addresses, while for the manager I can use an IPv4 address. Then to do that, select the desired IP address type from the option menu. If the IP address is static, then you have to enter the IP address, of course, and the other configuration parameters like gateway, network mask, and so on. And finally, the parameter IP address is the IP address of the. Changing the base station data activate advanced parameters. We can reduce the power by 8 decibel for external antenna operations, and the transmitting power of external antennas can be reduced. This may be needed in order to not to violate emission regulations in case the device is equipped with external antennas, and we can click yes or no to reduce or not the transmission power by 8 decibel. Later on, at the end of the training and the troubleshooting, we will see that we can also do finer adjustments. This parameter here may, however, then need to be done via the command line interface and directly under the Linux operating system of the base station. Then activating, deactivating the base station can be activated or deactivated. Base station synchronization. The synchronization and logical structuring of the base stations in clusters are needed for the correct operation of the DECT system and especially of the multi-set system. We need to have a radio connection between the base stations and the mobile phones, and we also need to have a radio connection among the base stations in case that we want to use the air interface for synchronization. Also, in case of handover, we have enhanced the requirements for radio overlap. To carry out the synchronization, you will need a plan of the cluster with the synchronization level for each base station. Come back to now synchronization level several times now. That synchronization level actually is the fundamental entity we need to deal with here. There are two methods of synchronizing the time slots of the base station. That's first of all over the air, meaning over the DECT interface, and that implies that the time slots of the DECT telephony are synchronized via the radio interaction between the base stations. However, we can have situations in which the DECT connection between specific base stations is not reliable enough, and in that case we have to do synchronization over LAN, which we will discuss now. And a base station, like we've seen before, shows its synchronization status via DLED. So base station synchronization. The general layout of the web configurator is shown here. So under base station administration, I see here first of all my base station, which is also the integrator or DECT manager. You can see that on the name of the base station, that's always local BS, and the DECT manager is also local on this machine. And then I've added here a new base station which is not yet synced. So initially, after activating a base station, you will have a no sync here, and sync appears later when the base stations can be synced either via LAN or via the air interface. So as soon as the base station is synchronized, in this case I did it via the air interface, then the status goes into sync, and that's also how the setup of the or how the view of the base station should look like if you have a system that is actually operating. So you see the base stations are synchronized. In addition, you see here below in the list of pending base stations, we come back to that in a minute, see another third base station which we not have yet added to the system. Come back to that later. Then, planning. In order for base stations to form a wireless network, they must synchronize one with each other to allow smooth transitions of handsets from one cell to the other, even when making calls. That's the handover. No handover is ever possible between cells that are not synchronized. That's a very important thing you always have to consider. They are synchronized via what is known as air interface, that means via DECT, exchanging DECT information, or this can also be done via LAN. In case of the DECT synchronization, the signal strengths between neighboring base stations must be sufficient for synchronization. Normally this implies that you have enough radio overlap. Again, for details on planning your network, you should look up in the OpenScape Cordless IP Service Guide. Please note that the synchronization within OpenScape Cordless IP always refers to a cluster, and that no synchronization is ever done between clusters. This is different when compared with MyPass Cordless IP version 1, where we could have synchronization across the media gateways. So we could have interlinked media gateways, and on top of that, we could also define synchronization across the media gateways. That is not possible here. Might be added at the future, but currently I'm not aware of any plans. So at the moment, there is no possibility of a handover between clusters. Then for the synchronization, we have a look at the base station overview, and this shows the list of synchronized base stations, and we see here several entities that you can configure, parameters we can configure: cluster, DECT level, LAN master, and sync slave, and we come to the detailed meaning now. The synchronization parameters you saw on the last mask are the following. So MAC address is the hardware address of the BSIP2 device. You can use that to uniquely identify the device. Base station is the base station name. DECT manager. DECT manager is the DECT manager to which these base stations belong. Cluster. I can now number my clusters and assign to each cluster a number, and to each base station of that cluster a number, just to label that this base station is a member of that cluster. DECT level is very important, starting with 1, 2, 3, 4, 5, and so on. It's the synchronization level within the sync hierarchy of the DECT network. That will be very important if we discuss the setup of the sync below. And LAN master, the base station acting as LAN master, is marked by a checkbox, and the sync parameter indicates, if you have slave in here, that indicates that the base station is synchronized via DECT or LAN. For the sync master, we do not have an entry in this column, or if you have an entry, it is meaningless. Now that's then shown here. So the synchronization, how do you edit the base station synchronization data? In the mask, you specify the cluster ID, you specify the DECT level. If that can be LAN master, you can make the checkbox here, and if that's a sync slave, you can select whether that slave takes its synchronization information via DECT, as it is shown here, or via LAN, which you can also select here from the drop-down menu. Now, synchronization, we have now to define the master-slave cluster procedure. And first of all, the sync master-slave relation means that the synchronization within the cluster takes place in a master-slave procedure. That means one base station is the master and saying, I'm going to have the synchronization, and I define what the others are doing. And this base station, the sync master, defines the synchronization cycle for one or more other base stations. You have to set up the synchronization hierarchy comprising all base stations of the cluster, meaning you have to set up a synchronization hierarchy until all of the base stations of the clusters are reached. Again, please note the situation is simplified by the fact that base stations only synchronize within the same cluster, and that the handover of handsets from one cluster to a neighborhood is not possible. With DECT multi-cell system, you can then manage up to 9 clusters. Synchronization, setting it up. Setting up the base station synchronization. First of all, you select the cluster to which the base station should be assigned to from the cluster option menu. Then you select the synchronization level from the base station, for the base station from the DECT level option menu. Please note that level 1 is the highest, meaning master synchronization level, and can appear only once in the cluster. Then mark the LAN master checkbox if the base station should also act as LAN master. And if synchronization via LAN is used, then there must also be a base station that's acting as LAN master. Otherwise, that can't work. And currently, and consistent with what we said before, the LAN master can only be configured on DECT in level 1. Then, from the sync slave option menu, select if the base station is to be synchronized via DECT or via LAN. So, synchronization sync level. During the synchronization, you have to assign a level in the synchronization hierarchy, which is called the sync level. Level 1 is the highest level. This is the level of the sync master and appears only once in each cluster. Then the rules for synchronization are as follows. A base station always synchronizes itself with a base station that has a better sync level. So meaning base stations of level 3 can sync with level 1 and 2, but not with level 4. Base stations of level 4 can sync with 1, 2, 3, but not with 5, and so on. If a base station sees several base stations with a better sync level, it synchronizes to the one which has the strongest signal. Not necessarily the better sync level, it's the strongest signal. If a base station, however, does not see any other base station with a higher sync level, then it cannot synchronize and will not be part of the cluster. And then synchronization LAN master. If the DECT connection between two connections, between two base stations doesn't seem to be reliable enough, for example, we have a metal wall or a firewall in between, to guarantee a trouble-free handover connection, then you can determine that the synchronization between these two base stations should occur via LAN. In this case, a base station with higher sync level will act as LAN master, and the base station with lower sync level is a LAN slave, and we have a LAN synchronization in contrast to an air synchronization. Currently, the LAN master must be on sync level 1. Advantages of the LAN synchronization, like as we said before, with the LAN synchronization, the base station with the higher sync level will act as LAN master, and the base station with the lower sync level is a LAN slave. And only one base station must be explicitly defined as LAN master, and that happens on sync level 1. The advantages you get by that are the following. First of all, you have a higher flexibility in the arrangement of the base station, as you do not need to perform a deck change, and you can also use fewer base stations since the overlapping area between the base stations is smaller. You only need to have an overlapping area for handover. You don't need the overlap criteria to fulfill for synchronization. And finally, the configuration of the system is simplified, as all base stations can be synchronized to one synchronization master, and they do not have to make complicated considerations regarding the overlap of decked radio cells. Requirements: I need to have low transmission delay. I need to have low transmission delay and low jitter buffer in order to have a good LAN synchronization, and therefore we have several prerequisites. Less switch hops as possible. That lowers the transmission delay and jitter, and also jitter, also higher bandwidth is good against transmission delay and jitter. Enhanced packet processing logic, like for example level 3 routing or packet inspection, like looking into the IP pockets to find whatever. This is certainly a negative impact on the transmission delay and on the jitter buffer, and that should be avoided for networks in which the unified BSIP2 base stations are connected. Also significantly increased traffic load on the switch in the range of maximum throughput, so meaning always operating at the limit, has significant negative impact on the jitter delay, and finally VLAN-based prioritization of the LAN packets is good to minimize packet delay and jitter buffer, and that should always be used for unified BSIP2 base stations. And then hints regarding the precision time protocol deviation deals with the fact that LAN synchronization is done based on a two-layer design. So first of all, we have a pure LAN environment, which is the precision time protocol environment, and based on that synchronization on the LAN level, the synchronization on the deck level is initiated. So first of all, native precision time protocol version 2 is used to synchronize a common reference timer across all base stations. And the quality benchmark for this precision time protocol timer across all base stations is 500 nanoseconds. That's a prerequisite of the LAN synchronization for DAC that we can establish with the precision time protocol and LAN timer that has a deviation lower than 500 nanoseconds between all species involved. Then, if the precision time protocol deviation does not continuously exceed this limit of 500 nanoseconds, and if it does, then we will start the corresponding precision time protocol procedure. If the precision time protocol synchronization is achieved, so we achieve the 500 nanoseconds, and then LAN master and LAN slave adjust their DECT reference timers to a common offset of the common precision time protocol reference timer. And the target level for this DECT synchronization is now then that we can have the DECT LAN synchronization lower than 1000 nanoseconds, and the good mean having it lower than 1000 nanoseconds mean that we have a good mean value of about 500 nanoseconds. Scenarios for the LAN DECT synchronization hierarchies: pure LAN synchronization in the first scenario. In the first scenario, we use a configuration where all base stations are arranged in a chain. That example cannot be used for air synchronization up to some certain extent, because with the number of hops we are losing the air synchronization. So this is predestinated to use LAN synchronization. In that case, we're using base station number 4. Base station number 4 is the LAN master, and all other ones, 1, 2, 3, 5, 6, and 7 are the LAN slaves. The configuration for this scenario is then shown on the next transparency, where we see the configuration for scenario 1. In the pure land synchronization, we have the base stations number 1 to 7. We have a deck level. We have a deck level that should be 2 here. That should be 1 here. So there was going something wrong. That one shouldn't go there, but like I depicted, and we have a land master here, and we have land synchronization throughout the entire cluster. Right, so then let's have a look at another scenario. Scenario 2 gives us a scenario for pure decked synchronization. In that case, we have several decked radio cells which overlap, like indicated in that picture. And prior to the configuration of the synchronization, I think I have to discuss and find where my middle of the world is. Or let me say, not middle of the world, middle of the decked cell, or middle of the cluster. That base station, which is in the middle, right in the middle of the cluster, should get deck level number 1. And from this deck level number 1, I can then look where are my next base stations. The next base stations are located at deck level 2. They can appear on all sides, so on the left, on the right, but also top, bottom, or you think that it's three-dimensional, out of the plane or into the plane. The next base stations then get level 2. Those level 2 base stations can then sync from the level 1 base station. And then we have level 3 base stations, which are the outermost ones, and they can synchronize either via deck level or to a deck level 1 base stations, or they can synchronize to deck level 2 base stations, or they can even synchronize to a deck level 1 base station. To which base station they actually synchronize depends on the one which produces the strongest signal. In configuration for scenario 2, in that case we have to put base station number 5 on the deck level 1 and then correspondingly distribute the other cells on deck level 2 or deck level 3. I think we have 3 here as well. Right, then a very interesting scenario, and the scenario that was not possible previously with Unify Cordless IP version 1. That's scenario number 3, the mixed scenario, where we have a set of base stations which we can sync via air. Then we have a solid metal wall, like fire protection, or if you are in a hospital, you have an X-ray, area which is screened, or anything like that. You can sync off, and between this border, the radio signals can't cross, so you have to use land synchronization through that. In that case, we put base station 4 on deck level 1, which is allowed to sync the base stations on level 2 and 3 here on top of the wall. That means those base stations can sync via air from the sync master, which is base station number 4. However, this would not be possible on the other side of the metal wall, and therefore for the synchronization of base station 7 I have to do something in addition. I have to sync base station 7 from base station 4 via LAN, putting base station number 7 into deck level number 4, and from deck level 4 onwards I can now again synchronize the base stations of deck level 5, 6 and so on. The configuration is shown here. We have here the deck level for the particular base stations. Base station 1, deck level 3, 2, 1, 2 and so on. Then we have base station number 6 synchronized from base station 4 via LAN, which then can be used to synchronize base station 7 again via deck, because that's on deck level 4 and that's on deck level 5. The section PBX profile defines how you integrate with the Unify communication platforms, and for this purpose you can define a PBX profile, and you can use up to 10 different voice PBX or telephony or VoIP provider profiles. Also in the original documentation, different ways how they are called. We talk here about the PBX profile. In the examples we discussed for that, I will deal with one profile for the OpenScape Business, one profile for the OpenScape 4000. Here you need one profile per IP media gateway, meaning per STMI, because each STMI has a different registration address. Then for the OpenScape Voice, you can again need one profile only because you have a central registration IP address. The PBX profile page allows you then to create a list of the systems providing voice over IP connections and other services for the phones of your cordless IP system. A settings provider or PBX profile, this is shown on the transparency. It shows in general the mask of the 10 profiles you can configure. And the first three examples give the examples for OpenScape Business v2, OpenScape Voice version 9, and OpenScape 4000 version 7R2, as mentioned earlier. You can always click on the edit button next to the profile, and the corresponding page with the settings will become opened. We first discuss the parameter in general and then go to examples. Here you see the PBX profile voice over IP provider section. Here you first of all configure the name of your connection, the SIP registration domain, the proxy server address, the SIP registration server address, the transport protocol, that can be UDP, TCP or TLS, and in case of TLS you can also enhance that to use the secure real-time protocol. And with the secure real-time protocol, you can then make the decision also to accept non-SRTP calls. As default settings, we have here port 5060. That of course depends on the protocol used for proxy server port and for registration server port. For example, you have to modify that to 5061 in case that you are using TLS. And we finally have the registration refresh time, which is per default 180 seconds. Then PBX profile redundancy settings. The redundancy are determined by the several types of the DNS queries. By default, we have in here an DNS type A, so meaning a host query. You can also select to have an SRV or different types of queries here. Then you specify whether you have an failover server that enables registration, yes or no, and then you have to specify the registration server and the SIP server port. Use the same protocol settings as you have specified for the main server. That is the redundancy. Then for the PBX profile network data of the service provider, you can use a particular outbound proxy mode if you want to have want to use a proxy for outbound dialing, and specify the corresponding outbound server address and the port number, and use the SIP subscribe for net MWI yes or no. Default here is no. So the outbound proxy server can be an outbound proxy in the local network provided by the local network provider, or if you have a public outbound proxy, then it can also be a public network IP address, which you may enter here. PBX profile DTMF over VoIP connections. For DTMF over VoIP connections, we have to specify how the DTMF tones are transmitted, and the default setting is here that we use automatic negotiation about the method. The methods that can be used here and that will be negotiated between A and B party are out-of-band RTP, SIP signaling messages, or in-band RTP. So that's the corresponding three possibilities you have with voice over IP telephony. Then PBX profile settings for codecs. In the settings for codecs, you can select the active codecs. We come back to that later on because we can actually activate additional codecs. That is the G722 codec, which currently doesn't appear here. These settings correspond to a narrowband voice transmission, which allows you to have 10 calls per base station. We will see later on that we can restrict that in the telephony settings to have higher voice quality but lesser telephony calls than we have in addition to the G722 codec here. Then RTP packetization time, 20-second signaling options, forward and session description, protocol inactive, and hold towards target transfer is currently set to no. The PBX profile, the number of parallel calls per base station depending on the bandwidth, actually writes down what I've already said. With the codec G11, A-law or mu-law, we have the narrow bandwidth for voice calls and can have at most 10 voice calls. The next station, when using either G711 or G729, still a narrow band mode, but due to the fact that we have to negotiate about the protocol or to mix those codecs here, the number of calls per base station is reduced to 8. And finally, if we use one of these codes or even the aforementioned G722 in wideband mode, meaning with high definition voice transmission, then the number of calls is restricted to 5. Then display of caller information from the calling party option menu, select which information is allowed to be transferred to the receiving party within the SIP header, meaning when we are dialing out which information do we give the other party, and the information is actually that is transferred is determined by the provider, so the provider doesn't need to transfer that. He always transfers the from. From is just the IP address from which the call comes from. You can then have a P-preferred identity plus the from information, or a P-asserted identity plus the P-preferred identity plus the from information. And what you transfer is then selected here. Then service codes for call completion. To busy subscriber or no reply, they can then be specified here per default *6 and #6, and they then can be used by the agent to configure the feature on their phones. Ring back if busy for *6 and ring back and no answer with #6. And then examples for the configuration that we see here is first for the OpenScape business. So I always first show the SIP configuration within the platform. Then we discuss the IP profile settings, and then the third part of the example we discussed the corresponding SIP user settings actually for the handset. So we didn't have the handset configuration so far, but just in order to complete this example, we just show that here as well. So configuring a SIP client, we have here SIP client 151 configured in the OpenScape business. Client 151 has several work point data. Authentication must be active. Password must be secure, so at least 8 characters. One thereof needs to be a letter. SIP user ID name and the corresponding realm domain for the SIP authentication. Then configuration of the voice over IP provider for the OpenScape business first. Domain can be the IP address of the SIP server. Proxy server address we can leave empty because we are connected in the same network as the OpenScape business, and the connection to the outer world is then made via the OpenScape business. Registration time, refresh time, and ports, and the default values and protocol is UDP here. The rest are standard settings. Then we go to the mobile device. And the mobile device, we haven't spoken about mobile devices so far, so we only discuss the voice over IP part, and that means in that configuration of the mobile device, I assign to the mobile device the authentication password, the username, the display name, and the voice over IP profile that is used for this handset. Then platform integration, OpenScape business. In the OpenScape business we have here the number 1008, and the number 1008 is configured for dynamic registration via TCP, and we also have a screenshot of that. No, we also have set up the corresponding security here. Then general information for the service provider in the voice over IP profile domain in unique proxy server address. We don't need proxy server port, registration server port, and registration refresh time. Just the default values. This is the IP address of the CSDA signaling manager of the 4000 and this protocol we are using TCP. In this case. Then finally the personal provider data for the handset corresponding to the OpenScape voice configuration are as follows. So I need to put in the authentication name here and the authentication password, the username and the display name and the voice over IP platform that we are going to use for this subscriber. Rest of the parameters are standard. Then finally, example number 3, OpenScape 4000, we are using a SIP-station configuration via UFIP. In this case, specifying a corresponding password. Yeah, that doesn't correspond to the screenshot we see later on. But in that first configuration, I actually use that password. Station number is 7700 and user ID and password is here. The user ID is the same as the station and password is 1234567 And then finally, it's UFIP, I said that already. And then finally, the attribute multiple B channels is added also for that station. Then the configuration is as follows. Domain, we can use the IP address here. Proxy server is empty. The proxy server port 5060. Registration server IP address is the IP address of the STMI. And that's in that case the 121 and the 130.11 network you see here. Registration server port, registration refresh time, and protocol we are using here is TCP. Again, remaining parameters are default. Then the personal provider data. As you see, I've modified the password here. So I specify the authentication name, the authentication password, the username specified in the MOSBCSU display name can be different from those, and the name of the provider profile. Please note that I've used the corresponding secure password here. That seems to be, to me, a little bit too secure for some 4000 configuration. I got that working, but later on had difficulties with that and returned to the returned to the original one, which was 1, 2, 3, 4, 5, 6, 7, 8, instead of using the more secure A1, 2, 3, 4, 5, 6, 7 password. However, but initially that did work as well. So OpenScape Cordless IP version 2 mobile devices. In that section we deal with the configuration you have to do for the devices, the registration and activation of devices and so on. So mobile devices, you can use the web configurator to register all handsets on the DECT voice over IP network for a connection. So that means handsets need to register twice. Actually, first of all, from the with the DECT network to become part of the DECT telephony, and then each handset needs to set up a web connection and register a SIP subscriber. On the administration page of the handsets, you have the add function. The add function you can use to register single handsets or to use the registration center to register groups of handsets in one process. So this is the possibility, one by one with the add function, or use the registration center to register groups of handsets in one process. You can add the settings for handsets, deactivate, delete them, and make further settings, for example, regarding the usage of directories or other network services. So mobile devices administration, we first deal with the administration. Actually, we spoke about that already. So you have here under mobile devices administration the list of mobile devices. You see the active devices here on the top level. You can see several data shown in that table. Shown in that table for each of the devices, starting with the IPUI, username, display name, DECT status, SIP status, type, and finally the firmware. What you can do here, you can add a handset to the list, you can delete a handset from the list, or you can click on the pen and edit the settings for one handset. Registering and deregistering handsets, the general procedure is as follows. You have to enter information for your handset, either the IPUI, if you want to restrict the registration to a specific handset. You can then enter the authentication code, or sometimes also called the PIN, manually or generated via the Generate Random PIN button. And then enter all configuration for the handset, then click on Register Now. Then the handset with the matching IPUI is now allowed to register, and if no IPUI is defined, then all handsets with in the range, meaning within the visibility of your DECT system, can register. This registration mode, if you click on Register Now, is on as long as it is defined in the registration center. Per default, that's 3 minutes. Once you've clicked Register Now, then you have 3 minutes time to register the handset, type in the PIN number, and so on. Well, that procedure is then shown here. So here I've omitted with the green block all the data which are currently not relevant for us. So in order that you see the most important parts. Most important part is that you specify an IPUI or not. If you don't, that's a MAC-like address of the handset, which uniquely identifies the handset. Then only this handset can register. If you leave it open, then all handsets can register. Then registration status, of course, now it's not registered. Authentication code, you can type that in here, or click on the Generate Random PIN button to generate a random number here. Then click on Register Now. This then allows the handset to register. However, instead of clicking Register Now, you can also do the following. You can also click on Set, and this then will save this data in incomplete form, meaning it will save the corresponding information about the mobile device, however, without registering the mobile device. That's shown on the next page. So the next page shows several information about registering or deregistering handsets, and in that case they are saved in the DECT status to register, which you can see here. So meaning that the information, all the information about that device we have entered is added, but no device currently is registered here. So when defining the mobile device parameters, you have to specify the following parameters: the IPUI, the International Portable User Identity, the registration status, the authentication code or PIN, Then the personal provider data, to which provider that telephone belongs, and which username and how to log on there. Then the online directories, the network mailbox configuration if the user has one. Finally, LDAP authentication if the user uses LDAP directories, group pickup, call manager, and finally the settings for missed calls and alarms. We go through them step by step now. Starting with mobile device parameters and mobile device. First of all, we discussed it already, putting in the IPY, if known, or leaving it empty and typing in a PIN number. Then personal provider data. We saw that in the examples for OpenScape Business, OpenScape Voice, and 4000. We have to specify authentication name, authentication password, username, display name, and select the voice over IP provider we've selected in order to allow the device to successfully register a SIP subscriber. Then mobile device parameters for online directories need to be set for the handset. I can select the corresponding online directories, online directory for direct access, the corporate directory for the internal key on the phone, as we saw before, and if we have automatic lookup for incoming calls via the internal telephone book, then I can also activate that here. Then mobile device parameters LDAP authentication. When LDAP authentication is needed to access one of the directories, then we need to configure that here. Then select with LDAP. I configure here, and then show other LDAP servers yes, no. The LDAP authentication type can be, for example, global. Then I have to specify for this LDAP the username and password for log on. Then again for the mobile device parameters now the network mailbox configuration. For the network mailbox configuration, you have to specify the call number or this SIP name URI as the network mailbox. Then this can be made accessible via the Unify Cordless IP telephone as well. Finally, group pickup. For the group pickup, I have to specify the call number for the group pickup or the corresponding SIP URI for the group pickup. Then I can pick up calls for other users which belong to the same pickup group. Then mobile device call manager. Call manager means that calls are accepted directly via headset or via hands-free method, and in order to enable that for a mobile device, I have to turn the accept calls directly via call manager option on. Then mobile device parameters. Missed calls and alarms. Finally, I can turn on the alarms for missing accepted calls, count for flashing LED, for missed calls, flashing LED, for missed alarms, flashing LED for network mailbox. By default, all these 4 alarms are turned on. Then deregistering handset is then the next actions I need to perform are on the handset itself, meaning I have to turn on the handset, start the registration procedure there, and when prompted, enter the PIN number which is needed to register the telephone. Then the handset registration center. Handset registration center allows you to register more than one handset by once. Therefore, you have to follow the corresponding procedure which is outlined here. The purpose is to allow you to register groups of handsets in one registration process. For example, if you have to deploy 1,000 handsets, you can do that here with one click. And handsets which are listed in the mobile device list and have registration status to register or to rec, as we saw before in our examples, so which are saved in an incomplete state, they can be registered together. The registration of the handsets can be either done immediately by start registration or time control. If I do that time controlled, then I have to specify the registration time in the format months, 4-digit year, 2-digit months, 2-digit day, hour, and 24 hour and minute. Or I can click Start Now. In any case, the registration duration parameter will be in effect, which by default limits the registration to 3 minutes. So this is then shown in the handset registration center GUI shown here. I see the mobile devices with status to register, status registering, and in total. With registration deck managers, with registration window open, name 1, current time, registration time, or click on Start Now. I click on Start Now, that's why all the other times are grayed out, and or in other circumstances I could also change the registration duration here if I interrupted the registration procedure. Then during this time, all handsets which have the status to register can become registered. That of course works quite well if you're having one person sitting down with all handsets, taking one after the other, clicking registration, then typing in the PIN number, then registering each headset. There are, however, certain coincidences or certain collateral effects if you have several persons registering the devices at the same time. Therefore, handset registration center remarks. So when the first handset tries to register, the base closes the registration window and finalizes the registration within a few seconds. So that goes rather quick, but important is that during this time, any second handset registration attempt would be rejected. Opens the registration window as long as defined within the registration start time and the registration duration parameters, just as we saw, and during that time then the next handset can register. However, if all handsets are tried to register in parallel, we have so many administrators and each one want to try a handset and they all want to do that at the same time, then a lot of them will enter the base one by one and will be successfully registered, but also other of these handsets might come at the wrong time when the base is closed and handsets currently cannot register, so they then will be rejected. To cope with these rejected handsets, so single handsets that are rejected, they can be registered either by a new registration process or just try it again when the registration window is open again, or register them manually. So we come to OpenScape Cordless IP version 2 telephony settings, where we will discuss several additional telephony parameters you can set in the Cordless IP system. That's shown here. Several port settings, default port settings, SIP port, SIP secure port, the SIP timer T1, the round trip timer, and then the SIP session timer, failed registration timer and subscription timer, T1 and subscription time in milliseconds, the other one in seconds. Then SIP security certificate, which we can upload, and also the SIP security private key we can browse and upload. SIP security password if the private key is protected by a password, and finally parameters for the quality of service for the TOS parameters for SIP and for RTP. Then audio quality, we already spoke about that. We normally have a narrow band per default, but we can enhance audio quality by enabling the G722 codec that we need to restart the system. All connections with mobile devices which are currently active will be terminated, and this will restrict the number of calls which are possible per base stations to 5 wideband calls. This also will enhance the other codecs to use wideband as well. So also this G711 AOMU normally will then only be able to have 5 calls per base station, however with increased audio quality. Settings for call transfer via the R key on the phone, via on-hook, and how to determine the target address from the address of record is the default here. Then next settings are the access code. Access code is needed, for example, if you want to make an external call, you need for an outdialing number, for example, a prefix 0 or a carrier code that needs to be dialed in advance. That can be added to the numbers from the incoming call list. So you just prepend the corresponding digits in front of that number from network directory or in general. And this setting, please note, this applies to all regions. Then call settings area codes, you can specify the country, Germany. International prefix is 00. Area code is 49 or 89. Local prefix is 0, and area code could be 89, for example, India. And then again, that also needs to be specified. Then telephony settings, call settings, the tone selection, which dial tones, for example, busy tones or whatever you hear. There are several tones, schemas for various countries. This example shows the settings for Austria. That's used to adjust the tones for your phones. And that completes the settings regarding additional telephony settings on OpenScape Cordless IP. In the OpenScape Cordless IP version 2 online directories, we deal with the settings of LDAP directories. In the OpenScape Cordless IP, you have 10 LDAP directories. You can see that loosely corresponds to the 10 voice over IP providers we are having, meaning that in case of 10 voice over IP providers, you can use these 10 LDAP directories, for example, or you could use these 10 LDAP directories, for example, to provide a directory for each of the PBXs as internal directory. So then we have the settings here. You can just click on the pen, as you might already have noticed, to open such a profile and then enter particular data. So for the online directories, you first have to specify the access to the LDAP data server. LDAP data server specified by a name. Enable the directory. The server address is an LDAP URI. So LDAP // and the IP address and the port number. Server port number default 389, like usual for LDAP. And finally the base DM. Base DM is used for searching participants, username and password. To search in the LDAP database, you have to specify the name filter and number filter. Then you can specify several additional filters. Finally, the display format and the maximum number of search results. So for the name filter, name are filtered here by common name and surname. The number filter, numbers are filtered here by telephone number or by the mobile number. According whether they match, additional filters are made on city, on locations, on streets, on street names. And finally, the display format is given as surname, comma, blank, given name, meaning last name, blank, comma, first name. And the maximum number of search results is 50. So based on the LDAP directory you're using, you have to specify, of course, the search parameter which are specific for your LDAP directory. In this mask, this is only a general example or hint how this can look like. Then specify what is in your LDAP directory. First name is SN, surname is given name. That's certainly wrong. Should be also have taken that from the handbook. That should be the other way around. So first name is given name, surname is SN. Usually in the LDAP notation, phone name can be home phone, telephone number. Office phone is the office telephone number. Mobile is the mobile number. email is mail, fax is facsimile, telephone number. Company can be denoted either by company, by organization, unit, street, city, country, and additional attributes, and the additional attributes can also be made dialable if you need that, for example, for an additional telephone number. Let's go to the system settings. System settings can be done for various type of entities, and we start with the access rights for the web configurator password. I can type in a new web configurator password here. I can also show that to myself in order that I haven't mistyped that, and then reset the web configurator password. Then CLI access can also be enabled. CLI access via a secure shell is then possible, and I can specify a password. If that password is longer than 7 characters, then the CLI access is activated, and the username for the CLI access is also CLI. Then capacity licensing. Licensing is in general done by an external license server. So licensing type is always remote CA. I select the deployment here and select the IP address of my CLA server. For example, I can use the CLA of the OpenSCIP 4000, of the OpenSCIP Business, or the OpenSCIP Voice here. And then provisioning and configuration. That's more or less something which comes from Gigaset, which is the OEM partner of OpenSCIP Cordless IP. For this product, they have a provisioning server which allows to provision configuration. Unify currently hasn't, so this is not important for us. Also, the auto configuration file method is under discussion, but not yet implemented. So we will start now. We will probably start that, if at all, at a later time. This could give rise to situations, or could support you in situations where you want to have multiple users or multiple user configuration, but it's still under discussion with development of the product meant to do that or not. So that's the auto configuration file and provisioning server, which is a possibility. Then finally, security certificates. The certificates you can use in a system can be uploaded and assigned here. So first of all, you can click Browse and upload a certificate by clicking here on the Upload button. Then it appears in the invalid certificate. Then you either have the possibility to accept or reject a certificate. If it accepts, then it's either moved here, if it's a CA certificate, or it is moved here, if it is a server certificate. That depends on the nature of the certificate then. So that's the configuration. To add a certificate, if a certificate is accepted, you can mark that. And remove that. Then it goes down. Here. So that's the configuration for these certificates. Then HTTP authentication on top of the authentication within the web configurator. You can also require HTTP authentication to access the web server itself. In that case, you need to specify an HTTP digest username and an HTTP digest password here under security. Then date and time. With date and time, you specify the time server, time zone, and then see the actual system time of the system, and act as local time server should normally be known. The system firmware allows you to update the firmware. The URL to the firmware is given here. You can click on Browse to upload or to change the corresponding file here, then a new file becomes uploaded, like you see that here. Then you can plan an upgrade by entering a 4-digit year, months, day, hour, and minutes. This only becomes accessible if you've uploaded a new one, which I haven't done prior to that screenshot. Then the activation can be either done at this planned schedule or immediately, and also immediately needs to be taken out before you can configure that time. And if you then save that page, then it tells you what your confirmed schedule is in this case immediate. So that's the upload of the firmware. Then if you upload the firmware to the DECT integrator or manager, then also the base stations become upgraded. Then save and restore. Allows you to save the settings to a file and to browse and upload a file and to restore the data from there. That's rather simple. Then in the same way, similarly reboot and reset. If you click on reboot and reset, then you can reboot DECT Manager or DECT Integrator or whatsoever. Or you can reset the corresponding device you are logged onto, for example, to a base station, or if it's a DECT Integrator, you can reset that also to a DECT Manager. Reboot and reset, you can do a manual reboot, or you can reset factory resettings, or resetting a device to another level. So OpenScape Cordless IP version 2 diagnostic and troubleshooting. With diagnostic and troubleshooting, we first have the integrator status window that appears on the status information integrator status, containing the device name, the device role, its MAC address, the IP address, the firmware version, date and time, last backup, number of DECT managers with deviating firmware, number of active base stations, number of pending base stations which are seen but not yet member of the system, and finally the mobile devices in the status. Registered, to register, or reset registration, which gives you an overview on the health and functional status of the entire system. The several parameters are then shown here again. I think I went through all of them on the previous transparency, so we can just go over the status information provided here. Just see integrator status, device name, device role, DECT managers. Some additional information possible below that what we saw. I want to mention here that's the number of DECT manager licenses, which is also shown, and the number of base station licenses, which I didn't mention, and I guess that is it. Then base station events. Base station events are shown under base station events SNMP, and you see here several base stations that have active radio connections, handover setup, handover release, unexpectedly terminated, that's call drop, went asynchronous, and so on. So you can see the information for your base stations in detail on this page. Then we have the incidents page, which allows you to download the information to a particular file. All the incidents which are seen by the DECT manager in your system are listed here on the incidents page. And on the incidents page, you see all the events and have the possibility to download them, to a file. Then you can, to get additional system log, you can define a syslog server. This is the usual Linux syslog server type. You can specify the server address here. The default port number is 514, and you can specify the corresponding log level that should be captured by this syslog server. Then you can add the events of your system to the syslog of the particular server. Additional troubleshooting can be done via CLI. So typical standard Unix command or network configurations can be done ps ls cat netstat top dfdu, so meaning process status, listing of file servers, and putting files to the output, network status, listing top of files, free disk usage can be performed with ifconfig. You can show which network connections of your system has. Then you have the UCI values for the configuration of the system that you can show or set. And with root access you have additional permissions. So you need the sudo command for that. You can run in TCP dump, for example. You can read the system log with log read -f. The where mi command, or the set power. Set power allows you to do further and refined power settings for the antennas of the particular base station in a more fine level down, or fine-tuning level than just with the normal and the reduced power you can see here. Then we have as example at the end showing what this analysis can do. I think one of it is TCP dump. That is around the TCP dump, and think that we have additional analysis to that tool available via the command line interface. So that then completes the session regarding the status information, and there with the entire training. I thank you very much for your attention, and wish you very much success with that program.